In this session, we're going to discuss bisection method. Okay, bisection method is an algorithm to determine a root of a certain function. Okay, so we're going to guess two values, and within these two values, we're going to determine the root of the equation. Okay, so bisection method is based on this theorem. An equation f at x equal to 0, where f at x is a real continuous function, has at least one root between x sub l and x sub u if f function at x sub l times function at x sub u is less than 0. Okay, so we have two values, the lower and the upper x. Okay, the lower bound and the upper bound. So when you substitute it to our function, it will give us two answers. If we're going to multiply the answer of the two guess value, if it's less than 0, it means between these 2 points, the guess 2 points is the root of our function. Okay, that's the concept of bisection method. Just to prove that we should have a different sign for our result. Okay, to determine there is a root. So let's prove it. So let's have this equation and this graph. In case x sub n and x sub u have the same result, there is a possibility that in between this point, there is a root of that equation. Okay, but there is also instances that if both have the same same sign, same result, positive or negative, there is a possibility that there is no root between these 2 points. Okay, two guess points. In this example, x sub l and x sub u, okay, we have both positive, but there's no root in between this. Same as with this, we have the same negative answer, both negative answers, but there's no answer. And no, there's no root between these 2 points. So it is not safe if we're going to choose if we're going to choose that if both answers of the upper limit upper point and the lower point is the same sign. There is a possibility there is a root between and there's no root in between. So that's why it is better to choose that one one value or one value of x will give us a negative result and one will give us a positive result. So in this example, okay, upper and lower. And in between these two, there could be a multiple root that we could solve wherein f at x equals to 0. So that's the basis of why we need to have a okay different sign result for our bisection method. Okay, so we are assured that there is a result, there is a root between the guess values. Okay, so that's bisection method, the concept of bisection method. So what is the algorithm behind it? Okay, first step, define your upper limit and lower limit. Guess two values. So x sub l should give us a negative result. X sub u should give us a positive result. Okay, so supply a value of x. If it's negative, so it will be considered as x sub l, and x if the result is positive, that x is equivalent to x sub u. Okay, and then afterwards, after determining the two guess value x sub l and x sub u, we're going to get the midpoint of this of the 2 points. We call it x sub m or x midpoint. Okay, so x sub l, x sub u, get the midpoint. We have the x sub m, and then Step 3, substitute to your equation. And if the result is positive, okay, so you're going to change, okay, yung value ng x sub u equivalent to x sub m. And x sub l is still the same. But in case if the result is negative, you're going to change x sub l equivalent to x sub m, but x sub u is retained. But in case x sub function at x sub n is equivalent to 0, that x sub m is already the root. Okay? Okay? Because root of the equation. Okay? So why do we need to change x sub l if the result is negative? Why do we need to change x sub u if the result is positive? Because in this example, we need to retain that it should be the point, okay? The root should be between the 2 points. So in here, x sub l, x sub u, x sub m, and it will give us a negative result. So para makalapit tayo sa tunay na root, we need to choose the nearer point to our root. Between x sub l and x sub m is nearer. So therefore, both negative, so the nearer negative will be chosen, okay, for the next iteration. That's why we're going to replace x sub l by x sub m when the result is negative. But in case if it's positive, so somewhere here, so we're going to replace x sub u by x sub m. Okay? Then afterwards, after replacing x sub l or x sub m based on the result, so let's move on with step 4. Since bisection method is an approximate algorithm, so we're going to determine if the result is acceptable. So based on the desired error, acceptable error. Okay, so we could compute for the absolute relative error by following this formula. X sub m new minus x sub m old all over x sub m new. By the way, this should be absolute times 100. Okay, so why is x sub m? Because x sub n is the root that we that's the equivalent of the estimated root, not the x sub l, not the x sub u, but the x sub m. Okay, so afterwards, so we're going to check what is the error, and then we're going to compare it to the desired error. Okay, if it's more than the error, we're going to repeat step 1 up to step 5. Okay, and in case if it's less than, we stop the iteration. That will be the answer. The last x sub m, okay, when we stop, that will be the root of the equation. Okay, so let's have an example. So let's have this equation. X cubed minus 0.165 x squared plus 3.993 times 10 raised to negative 4. Okay, so first, using bisection method, we're going to determine the upper limit and the lower limit. Lower should give us negative answer. Upper should give us a positive answer. So let's suppose we're going to guess 0. Substitute to our equation 0. If it's negative, we're going to use it as x sub l. But in this example, if it's 0, it's 0.004. So therefore, it's incorrect. So why not negative 1? It's negative. So where we get the x sub l na ngayon. Now, let's proceed with positive. So it could be 0, since it's already 004. But for me, it's better na 1 for easier. Para malayo doon sa 0 na yon. Okay? Basta as long as positive siya, okay? Positive ang result. When we substitute your upper limit, it's okay. Okay? So in this example, I'm going to choose -1 for x sub l and x sub u 1 because x sub l will give us a negative, x sub will give us a positive result when we substitute to our equation. Then after determining the x sub l and x sub u based on the algorithm, we're going to get the x sub m. So -1 plus 1 divided by 2, 0. That will be your x sub m. Then afterwards, after getting this, you're going to substitute to it to our equation, and then this is the result, 0.004. Since this is positive, we're going to replace upper limit by x sub m. So from 1, it will become 0. Then -1 plus 0, -0.5. Okay, so that will be our new x sub m. Then substitute it to our equation, we have negative 0.16585. Okay, and definitely the error is big since this is our second iteration. So to get the error, by the way, the first error that we're going to get is from the second iteration. Okay, since first iteration natin, wala tayong dalawang x sub m. So that's why sa step 2 pa. So sa step 2, ang old natin is 0, ang new natin is -0.05. So that's why this will be our divisor. Okay, so using the absolute relative error, this is the error. Now, let's check the third iteration. So, since negative to, ang papalitan natin ngayon is yung x sub n, we'll replace x sub l, so that's why it becomes -0.5. So retain 0, get the midpoint, we have -0.25, and then substitute to our equation, we have -0.02554, and then the error is still 100%. So by the way, in this example, our acceptable error is 0.01%. It should be equal or less than this. Okay? So since this is negative, so we're going to change what? X sub L or X sub U? It will be X sub U. X sub L rather. Okay? Negative, replace X sub L. So from point -1 to -0.25, X sub M. Okay, so you're going to copy it here. X sub U is still 0. So get the midpoint, we have -0.125. Substitute. This is the result, -0.00413. As you can see, your function at x sub m is nearing to 0. So it means we're getting the root. And then we have this error. Now let's proceed. Since this is still negative, we're going to replace x sub l. Okay. Then continue. So we have -1.25. Wait, I'm just going to check. Yeah, correct. -0.25, -0.0449. So negative. So I'm just going to continue. Okay. As you can see here, okay, your error, your f sub m is nearing to 0, which is correct. Okay, so 0.06 is still greater than the desired error, so we're going to continue our computation. So I'm just going to drag this. We're going to stop when it's less than or equal to error, this error. It's 0.0087. And we have 19 steps. Okay, and then the x sub m, this is the result. This is the answer, negative 0.0437355504, which is the acceptable. As you can see here, para malaman nyo kung tama na yung answer ninyo, if you have the correct answer, okay, so you're going to check if only few bits, only few numbers being, uh, only few numbers is changed when you iterate the solution. Okay, so it means the error is lessened. Okay, so if you want to go further, okay, you could get a 0% error, and this is the result. Okay, so that's bisection method. Some more example on the next video lecture. Thank you.